All right, about lab 10, trying to give you some feedback. So let's actually take a look at the description. We're going to use a ultrasonic distance sensor, a PIR motion sensor, and also the SenseHat emulator. These components have already been explained in lectures, so you basically just use the same thing, but you will be doing something a little different. So if the motion is detected, the corner LEDs will be lit at in red. If motion stopped, and they turn green. And so the purpose of this, it really is just to help you digest what you've learned in the lecture, so you can actually know how to use them in your own program. And the distance sensor will measure the distance of the object if it comes into range, given a maximum range of 0.4 meters. If it's out of range, then there will be nothing on the LED matrix. Now, to have nothing on the LED matrix, you can simply just call the SenseHat clear method. That will do the job. And that's pretty it. Then we have, some tips that I gave you. I already gave you a starter code for displaying the digits on the LED, which you could potentially struggle. So I gave you this code already, although I only gave you the code to display 0. But I'm glad to see that most of you have got to figure out how to display different numbers. Now I'm going to show you my solution. You have done your various different flavors, but this is the solution I provide you. Typically, it's clean. I like clean solution. So, so what you do is you have a class member of this sense digit, and we're going to actually have sort of the image of the numbers in terms of the binary values, drawing as if you're drawing on this LED matrix. 1 means is on, 0 means off. And essentially this is a simple way to draw an image. This is very much like your very basic alarm clock, a digital alarm clock. If you know those numbers, how are they displayed? Well, they use LEDs, but there's LED probably in different shapes. How is it illuminated with just a kind of bars instead of dots like pixels? But the pixel obviously give you better resolution. In terms of our SenseHat, the resolution is not that great. It's, 8 by 8. It's but that's okay for our programming purposes. So as you see, you can make out the image. This is 0, it's 1, 2, right, and so on. So you have 10 digits in this array. And what you simply have to do is the number we want to display, we use that number to find the image in this list. Okay, if it's 0, then this is the 0th element right here. Okay. And the reason I do a modulo operation here, just in case somebody passes a digit that's greater than or equal to 10, and then this will only display the least significant digit. That's really the intention of this, showing a single digit. Well, could you, enhance this class to show 2 digits? Yes, you could. So that's the alternative way. Now, what I do here is instead of touching this, I'm going back to this lab10.py. Now, here's one more little detail here. The SenseHat digits, pay attention to the name. In the name, the word should be separated by underscores instead of dashes if you intend to use the file as a module that you want to import. this is kind of the constraints on the naming. So you see how I import sense digit from this module. If it's dashes, it won't work. Okay. In this lab 10 here, this is something optional, just to get rid of this warning message of a no echo when this distance sensor not detecting the object properly. It doesn't receive the echo because the object somehow moved that way too quickly before it can measure. So anyway, this is a little bit of warning that they say I don't like to see, so I get rid of this. This is the same code that I've shown you also in the home security dashboard example. Okay, so you don't have to worry too much about this, but this is just something nice to have. So here we're going to make an object of distance sensor, a motion sensor, and sense hat, which is emulator right here. And if you use a real thing, of course, this will be essentially just change the library, but we're doing the emulator here. I define two functions here. One function is to show corners. Showing the corners is just as simple as use this set pixel to basically change the color of a pixel. Add these four corners, 0, 0, 0, 7, 7, 7, 7, 0, right? And then also have another function here showing the distance, which we want to show 2 digits, right? So the distance is a floating point number. And what we're going to do is because we want to show the 2 digits in centimeters. So the number you're given is in meters. So you would multiply that by 100. You get the centimeters, which is still a floating point number. I'm going to round that up into an integer. Okay, so now we got a integer in centimeters. Now, this if condition here, again, this is about the robustness of the program. Although you don't necessarily have to worry about this much because the way we use it, this distance will not be greater than or equal to 100. But again, in your function, this is just one of those things about when you program, you need to have, you need to think from all angles. Your code should not have holes as much as possible. So anyway, here, if the digits are greater than or equal to 100, nothing to do because it's beyond our range. We don't want to display that. Not a big deal. It's optional for you. So to display 2 digits, it's as simple as calling this show digit method on this sense digit object. And the first digit I want to display is the most significant digit, right? The 2 digit on the left. You divide integer division by 10. That will give you the first digit, correct? The second digit, you simply just do a modulo operation. This will give you a second digit, right? This is a decimal number, so it's a base 10. This is how you do it. And then the way to draw these numbers in different positions, this is the starting point, the top left corner where you want to display that first pixel of the digit. So we're going to pick this 1, 2 position, which is the 1, 2 position basically is, 1 is X, right? X is this, let's see, X, yeah. So X is on this horizontal line. So if it's a 1, 2, that means 0, 1, and 2 is on a y-axis, 0, 1, 2. So the first digit will start from this pixel. We know the number will be displayed in, 3 pixel width. Okay, so you can display up to 3 pixel width, and then we're gonna leave some gap. So the second digit we want to display from here, which is, basically on the x-axis is 1, 0, 0, 1, 2, 3, 4, 5. And then we still have a 3 pixels horizontally to display the next digit. Okay, so Again, you can display in different places, but there's only a few variations for this. So this is what I do here. I want to display 2 digits in just 2 different locations. And then the main function here. So you first want to clear the sense hat, because once you stop the program, the sense hat could be left with some value, something displayed on the LED matrix. So I want to just clear it as a starting point. And then we're going to make an object of a sense digit. We'll pass in an object of a sense hat. And then the most important thing here is this. We register 4 even handlers, 2 even handlers for the motion sensor, 2 even handlers for the distance sensor. Okay. The motion sensor, when there is a motion, and I've provided examples on these things, and I specifically explained what you need to pass in is a function or a lambda expression, something that's callable. You cannot provide a value. If you just call the function, if you just remove this, you're essentially calling this function will return, in this case, it will return nothing. And then you're assigning none to this one motion. So you're not registering the even handle at all. You need to pass in a lambda expression or a function. In this case, what I do is, because really you just turn that function into a lambda expression, because we want to pass in a couple of parameters. I cannot use show corners directly like this way, because this will accept a function that will be provided a optional object, which is the PRR sensor itself. And there's no, it's not really using the parameters that we need to use here. So what you do is you call this function as part of this lambda. This lambda is now a callable function. So whenever there's motion, this will be called. When this is called, it will execute this statement at that time only. If you don't have this, the program is going to run through this. When it sees this statement, it will run this, call this function, execute it at this time, and only at this time. And this will do something, and then this will return nothing, which is none. This function doesn't return anything. And the none will be provided to one motion. There's no even handler here. You're not setting any value. And it will pass this on. And that's it. There's nothing else. So the reason that most of you are actually doing a forever loop, because the even handlers are not doing anything. You're trying to call this repeatedly. And that is not how you're supposed to use it. Okay. Use lambda. All right. So this is a same thing with the other ones. Now, one more thing here is when in range. When in range, this lambda takes one parameter. This takes one parameter. This parameter is actually the distance sensor itself will be passed in. And so here, inside the lambda expression body, we need to get the distance value, which will be passing here, and then we will display that on the sense hat. All right. And if it's out of range, it will simply call sense.clear. Now, in this case, you can actually just call sense.clear. Let me see. Because we're not taking any parameter, so even if this is trying to pass a parameter, it will just simply ignored. It will not pass a parameter. This is all we need to do here. So let's actually run this. All right. And then let's go take a look at this sense hat emulator. All right. Let's see if I can make this a little bigger. make this a little bigger so it's easier for you to see. Okay, I'm just gonna use an object. I would recommend you use an object. Do not use your hand. Your hand is kind of, kind of flimsy for the distances to detect. Use some relatively large object. So so now you see motion. Now it's actually, there's a distance 40, 36, right? It's right here. And the motion, you see the motion turn, off and on. If a motion is off, now it just clear the whole screen. So if I take the object out of the way, and now the screen is cleared, but also in the meantime, because the event handler, when there's no motion, we're gonna also set the corners to green. Okay, so that's what's happening here. Now there's a motion to turn to red, right? And then it display distance, and there's still some motion or not motion, whatever. It depends on what you're doing here. Try this out. Okay, this is what I intended for you guys to do. You have somehow managed to get something there. Not quite there because your event handling is not correct. So I hope you can learn from this. That's it, and that's what I'd like to explain. This is the event handling is important. When you actually use the event handler, that is going to be running in a background thread. And that's why it's going to, is able to trigger a function call when something happens. So anyway, that's it.